Okay, sorry about that. We had an unexpected fire drill for the building, so that was a fun little surprise. To get back to what we were talking about for leading into what the value of a means for the form or the function of the form y is equal to a over x. Again, if a is positive or greater than 0, like we have here in this example, we are going to have a hyperbola with branches in the first and third quadrants, and that'll always be true. If a is less than 0, so for example, let's say we have y is equal to negative 4 over x, like we did in the first example. If a is less than 0, in other words, the number a, or the letter a, that value, is negative, then we're going to have branches of the hyperbola in quadrants 2 and 4. It's a good way of looking at it. With these two examples, it's kind of nice to make the assumption, or at least I guess in this case, it's nice to make the assumption that if you have a positive 2, it's kind of like having a positive slope. So you would have the two quadrants that would give you a positive slope in your x and y coordinate plane. For that negative value, if your a is negative, it's kind of nice to make the connection that your 2, if you were to connect your two quadrants, you would end up with a negative slope in your coordinate plane. So that's kind of a nice way to remember your a values and what quadrants they correlate to. As the absolute value of a increases, so the absolute value of a increases, the branches of the hyperbola are going to move further and further away from your axes. So I want to give the example y is equal to 8 over x. Y is equal to 8 over x. Obviously, 8 is a positive number, so you're going to expect your branches to be in quadrants 1 and 3. But what's nice about this, or as this a value, the absolute value of a increases, so obviously here we have 8. So if it was negative, we're not looking at the positive and negative values. We're looking at the actual number here. As that number increases, we're going to get further and further away from our axes and our origin. So if I plotted this point, what you're going to start noticing, and this is obviously not completely accurate, but you're going to notice that these values, these branches, are going to get further and further away from your axes.